Okay, for the next one, use the factor theorem to determine whether x minus c is a factor of x plus f of x. So here's the polynomial. You want to know if this is a factor. Well, one way to do it is to simply divide this into this using long division. And if the remainder comes out to 0, the answer would be yes. If the remainder does not come out to 0, then the answer is no. Or you could use your calculator, okay, and do this. Here's what we know. X minus c is a factor. The remainder theorem tells me that x minus c is a factor if f of c is 0. F of c is 0. So basically all I have to do is write this as x minus c. So that would be x minus a negative 10. So you plug in negative 10 where the x is, and if you get 0, the answer is yes. Now the way you would do it in the calculator is you would take negative 10, store it, hit x. Okay, so that puts the negative 10 where the x is, hit enter, and then we type out this polynomial. So we have x to the third plus 8x to the second minus 18x plus 20. Okay, hit enter. And with the number I get is actually going to be the remainder. Okay, so here's what I get, 0. So the answer is yes, it is a factor. If I'd gotten anything other than 0, then the answer would be no. So let me clear this. Okay, 18 would be the same way. It's x plus 11 over 3. So if I write that with a minus, that would be x minus negative 11 ninths. So you would take negative 11 thirds and store it in the x like I did in the last problem. And then type out the polynomial here, hit enter. And for number 18, you will also get 0. So the answer is yes. Find a bound and the real zeros of the polynomial function. Okay, the bounds basically are determined by using the coefficients of this polynomial other than the coefficient of the lead term. So you're basically dealing with negative 3, 5, 9, 1, and negative 2. And you're finding two numbers, and then you're picking you're taking the smallest of the two numbers as your bound. So the first number you find is the largest number between 1 and the sum of these coefficients, but they have to be absolute values. So basically you're adding 3, 5, 9, 1, and 2. And of course the largest one is going to be the sum of those numbers. Now for the second number, you're going to take simply the largest coefficient, the same ones, negative 3, 5, 9, 1, and negative 2, but they have to be absolute values. So it's going to be the positives of those. And obviously the largest one is going to be 9. And then you add 1 to that. That's 10. And then you compare 10 with the other number, which of course is going to be larger than 10 because you're adding 3, 5, 9, and so forth. So 10 and negative 10. Once you find the smallest one, you simply take the positive and the negative, negative 10 and 10. Those are your bounds. Okay. Number 20 has some zeros of a function with real coefficients, and they want us to find the remaining zeros. Well, here's the deal. We have a theorem that tells us that if a function has real coefficients, complex zeros have to come in pairs. So that means if I tell you that I is a 0, then you know that negative I is a 0. If I tell you that 2 plus I is a 0, then 2 minus I is a 0. So in other words, it's complex conjugates. If you have one complex zero, then the conjugate of that is also a zero. So in other words, if a plus bi is a zero, then a minus bi is a zero. So in this one, they tell me, okay, degree 3, and it has zeros of 3, and notice it's degree 3, so you expect 3 zeros. So I've got 3 and 1 minus I. Well, if 1 minus I is a 0, then the conjugate of that, which would be 1 plus I, would have to be a 0. So the answer to that one is C. Now the next one is degree 6, and it gives you 1, 2, 3, 4 zeros. So there's 2 missing. This again is fairly easy because 2 plus I is a 0. So 2 minus I has to be a 0. Minus 4 minus I is a 0. So that means that the conjugate of that, minus 4 plus I, has to be a 0. So for 21, the answer is A. Okay. 22. Find the domain of the composite function f composition G. Okay, so that means it's the all x in the domain of this, such that g of x is in the domain of f of x. Well, the domain of f of x is all numbers except -9, because -9 and 9 is 0, so you can't divide by 0. So that would tell me that x plus 7 then cannot equal to -9. But if x plus 7 cannot equal to -9, bring the 7 over, that tells me that x cannot be a -16. So for 22, the answer is -16. Okay. Now for this one, again, it's a composition function, so if it's f composition with g, it's a set of numbers in the domain of g, such that g has to be in the domain of f. Well, because here I have a square root, whatever I put under here has to be greater than or equal to 0, which means this quantity right here has to be greater than or equal to 0. But if I solve that inequality for x, that would tell me that x has to be greater than or equal to -5. Okay, so for 23, the answer would be D. Okay, determine whether the function is 1-to-1. Okay, 1-to-1 means that for every x, there has to be 1 y, and then the converse has to be true. For every y, there has to be 1 x. But notice here, these 2 arrows here, if I go back for this value, it's not a 1-to-1. It's just going to 2 values. So the answer to this one is no. Okay. 1-to-1 has to be a 1-to-1 correspondence. For every x, there's 1 y. For every y, there has to be 1 x. Here, for every x, there has to be 1 y. For every y, there has to be 1 x. So if this were, say, -20 and 19, and say -20 and 20, it's not a 1-to-1 correspondence. Okay. But for 25, everything works fine. That's 1-to-1. The answer is A. The next one. Decide whether or not the functions are inverses of each other. Okay. 2 functions are inverses of each other if you take the composition of one with the other. It has to give you x. Okay, so here's the way you do it. You replace this x by this quantity right here. So you put it right there where the x is. So that means you're multiplying this by 9. If you do, that's going to give you x plus 9, and then minus 9 is going to give me x. Okay. If you put this in here, multiplied by 1/9, I get x minus 1, and a 1 gives me x. So this one works. Yes, they are inverses. This one, notice though, if I put this quantity here, multiplied by 7, there's no way I'm going to get an x out of that. So for B, for 27, the answer is B. No, they're not 1-to-1. 28, the function f is 1 to 1, find its inverse. Okay, so again, if you look at this graph right here, this is a parabola. This is a parabola with vertex at 0, 5, and it goes up this way. At 0, 5, it goes up this way. Okay, so the domain, this is the domain, x greater than or equal to 0. The range goes from 5 to infinity, because it goes up this way. Okay, when you find the inverse, the domain and the range are reversed. So whatever the domain is here, which is y greater than or equal to 0, that becomes the domain of the function. So just from that alone, I can figure out here that the answer for 28 has to be D. But if I wanted to get this, part right here, I would simply put an x here where the f is, put an x right here where the f of x is, put a y right here where the x is, that will be y squared, and solve that for y. Taking the square root, you're going to get this quantity right here. Okay. 29, just a calculator problem. Approximate using a calculator, so I want e to the power of 4.7, so it goes second e, and then 4.7, hit enter, and I get 109.947. Okay, that's answer A. Answer A. Okay, and this one here, a rumor is spread at an elementary school with 1,200 students according to the model right here, where N is the number of students who have heard the rumor and D is the number of days that have elapsed since the rumor began. How many students will have heard the rumor after 5 days? Well, you just put 5 right there. So again, with the calculator, parentheses, evaluating this thing is just plugging in, and for 30, the answer comes out to 661 students. Okay, 31. If 3 to the x is equal to 6, what does 3 to the negative 2x equal to? Okay, well, that's just a matter of taking this equation. And how do I get 3 to the negative 2 here? Well, I take this side to the negative 2. If I take this side to the negative 2 power, that gives me 2 to the negative 2x. But if I take this side to that power, I have to take this side to that power. So 6 to the negative 2 is 1 over 36. So for 31, the answer is A. Okay, solve the equation. 3 to the negative x is 1 over 27. Well, the easiest way to solve this equation is to write 1 over 27 with the same basis is. So 1 over 27 is equivalent to 3 to the negative 3. 3 to the negative 3. So I have 3 to the negative x. I have 3 to the negative 3. If the base here and the base here are the same, then the exponents have to be equal. Well, that would tell me that negative x has to be negative 3. If negative x has to be negative 3, then you cancel out the negatives and you get 3. So for 32, the answer is D. In the same way, for number 33, this is 3 to this power. 27 can be written with the power of 3, 3 to the third. 3 to the third, okay? And 3 to the 3x minus 6, so that means that 3 to the 3x minus 6 has to be 3. Okay, 3x minus 6 has to be 3, which means 3x has to be 9, which means x has to be 3. So the answer to that one is C. Okay.